At the launch of the program, we have a knowledge of 3 neurons that's automatically loaded, and these neurons have actually been taught using that particular track. If I hit the run button, the neurons are going to control the steering angle of the car based on what is seen through the windshield, and which is represented in this upper left window right here. Now let me stop it. And to show you how these neurons were actually created, I'm going to forget the current knowledge. So we can see the number of neurons is actually 0. And we're going to start from scratch. So if I hit run, the car stops immediately. No neuron responds because the knowledge is empty. So at that point, I'm going to teach that in that particular situation, the car should go straight. So I'll just hit the enter key and it commits 1 neuron. The action that took place here is that the pattern seen through the windshield is associated to the action keep going straight. And now if I hit the run button using that single neuron, we can see that the car can go a little further on the road. Now it stopped because the pattern which is displayed here is too different from the one stored in the single neuron we have currently in the knowledge. So I can, using the left arrow key, I'm going to tell the neuron in that particular case, when you see that pattern, then turn a little bit to the left, and I'll press enter. This actually commits the second neurons, and if I hit it run, the car should be able to go a little further. Okay, new pattern again. This time I'm going to use the right arrow key and teach the car in that particular case. I don't want it to go outside of the road, so we're going to steer to the right, press enter. A third neuron got committed, and I'll hit run. So it's managing that pretty steep turn, and then this one, and I think we should be fine. So I'll increase a little bit the speed, and that's it. So with 3 neurons, we're able to control the trajectory of that car on that simple track. Let me stop and show you the content of the knowledge. So in this window, it shows the content of the 3 different neurons we have committed. You can see number 3 here. We're looking at the third neuron that was created. In this little image, we have a picture of what is seen through the windshield. The plot here actually is just a representation, one-dimensional representation of the image into a vector of 256 components. And this is this actual data that is stored in the memory of the neurons. And the other information of importance here is the category. It's a code that specifies is converting into the steering angle. So we can see that we have the different pattern, the 3 patterns that were taught earlier. Now let's see how the car will adapt if I use a different road. So I'm going to clear the background, keep the same knowledge of these 3 neurons we just reviewed, and draw a new track that has nothing to do, like something like that. Now I'm going to hit run, which means that with the exact same knowledge, we're going to see how the car performs on that particular track. And if at one point the neurons do not recognize a new situation, then the car will stop. If not, it will continue. There we go. We can increase a little bit the complexity by using a different background, like a real image. So I'm going to load one that I have in store here, along with the predefined knowledge for this particular track. Okay. In this case, we have 9 neurons, and I'm going to hit the run button and see how the car behaves. I'll wait until it turns, does the full loop, and stop. Now let's take a look at the knowledge. It's a little more rich, since the pattern this time seen through the windshield is actually a gray level image, where we can see tire marks and more details along the edge of the road. So as a result, the vectors have more variation that we can observe also in the plot. And we have 9 neurons. There were more variations to be taught so that the car stays on the track.